This video is about sum and product of roots in quadratic function. For quadratic function, f of x equals ax squared plus bx plus c. We know there are two roots. Sum of x1 and x2 equals same denominator, 2a. Negative b plus square root b squared minus 4ac minus b minus square root b squared minus 4ac. Cancel. Negative 2b over 2a. Reduce negative b over a. So we get x1 plus x2 equals negative b over a. So negative x1 plus x2 equals b over a. b over a equals negative x1 plus x2. If we use s for x1 plus x2, I will get negative s. x1 times x2 is a product. P plus q times p minus q equals p squared minus q squared. Negative b is p. Square root b squared minus 4ac is q. P plus q, p minus q. So we get negative b squared minus square root b squared minus 4ac squared. Simplify. 4a squared b squared minus b squared minus 4ac. Do not forget this parentheses. Then distributive property equals b squared minus b squared plus 4ac over 4a squared. Cancel. Reduce c over a. So c over a equals x1 times x2 equals p. In this way, we got Villa's form of a quadratic function. First of all, we will take a out. X squared plus b over ax plus c over a equals a times x squared. b over a is a negative s x. c over a is a p. We call this Villa's form of a quadratic function. Let's talk about conjugate root theorem. Complex conjugate theorem. If a complex number a plus bi is a root of a polynomial function, then the complex conjugate a minus bi is also a root of the same polynomial function. For example, if 2 plus 3i is a root of the polynomial function f of x, then 2 minus 3i is also a root of f of x. Example 1b, find a quadratic function with 2 plus 3i as a root. x1 equals 2 plus 3i. Then x2 equals 2 minus 3i. According to this complex conjugate theorem, s equals x1 plus x2 equals 4. p equals x1 times x2 equals 2 plus 3i times 2 minus 3i. We do know a plus b times a minus b equals a squared minus b squared. Then for complex number, a plus bi times a minus bi equals a squared minus b squared I squared. Since I squared equals -1, so we get a squared plus b squared. We will get 2 squared plus 3 squared equals 13. Then according to the Vedas form of a quadratic function, y equals a x squared minus sx plus p. Since we are looking for one quadratic function, to be simple, we just make this a equals 1. So we get y equals x squared minus 4x plus 13. E. Irrational conjugate theorem. If an irrational number a plus square root of b is a root of a polynomial, then the irrational conjugate a minus square root of b is also a root of the same polynomial. For example, if square root of 2 plus 3 is a root of a polynomial function f of x, then 3 minus square root of 2 is also a root of f of x. Do not write down square root of 2 minus 3 is also a root of f of x. Make sure it's a plus square root of b and a minus square root of b form. Example 2b. Find a quadratic function with the square root of 2 plus 3 as a root. x1 equals 3 plus square root of 2. x2 equals 3 minus square root of 2. So s equals x1 plus x2 equals 6. P equals x1 times x2 equals 3 minus square root of 2 times 3 plus square root of 2 equals 3 squared is 9 minus square root of 2 squared is 2 equals 7. Y equals, to be simple, let's make a equals 1. X squared minus 6x plus 7. Let's go to question 5. Find the quadratic function if for -1 are two roots with the y-intercept -9. We will use Vedas form. x1 equals 4, x2 equals -1, s equals x1 plus x2 equals 4 minus 1 equals 3. P equals x1 times x2 equals 4 times -1 equals -4. So we have y equals a x squared minus 3x minus 4. The intercept means f of 0 equals -9. So f of 0 equals a times -4 equals -9. Then we divide it by -4 both sides. A equals 9/4. Final answer is y equals 9/4 times x squared minus 3x minus 4. I just plug back into this function. 9 over 4x squared minus 27 over 4x minus 9. Let's go to B. 2 plus 3i is 1 root with a y-intercept 7. So we know x1 equals 2 plus 3i. x2 equals 2 minus 3i. Sum equals 4. Product of those two roots equals 2 squared plus 3 squared equals 13. So we can write down the Villadas form. A times x squared minus 4x plus 13. F of 0 equals A times 13 equals 7. Divided by 13 both sides. A equals 7 over 13. So y equals, we plug A back to this function. 7 over 13 times x squared minus 4x plus 13. 7 over 13x squared minus 28 over 13x plus 7. Let's go to C. Negative square root of 6 minus 3 is 1 root with a y-intercept -1. So x1 equals -3 minus the square root of 6. Then x2 equals -3 plus square root of 6. S equals -6. Product equals -3 minus the square root of 6 times -3 plus square root of 6 equals -3 squared minus square root of 6 squared equals 9 minus 6 equals 3. So Villadas form y equals a times x squared minus sx, so plus 6x plus 3. F of 0 equals a times 3 equals -1. Then we divided by 3 both sides. A equals -1 over 3. Now we plug back into this function. Y equals -1 over 3 times x squared plus 6x plus 3. Distributive property -1 over 3x squared minus 2x minus 1. Be careful when you write down your roots. It has to be rational number plus irrational number so that you will get the correct conjugate of this root.